Hey, Nathan here. Welcome back to another video game mathematics video. In this video, we are going to take a look at Bezier curves. And a Bezier curve is a pretty neat topic in terms of mathematics, but also useful in gaming. For example, if you want to create some form of bullet or animation that you want to have the object travel in a path looking like this. This is achieved with a Bezier curve. Okay, so let's take a look at the mathematics behind this first. So in order to fully understand this, we need to know linear interpolation or LIRP. For example, let's take a line, which is 2 points, point 0 and point 1. If you want an object to travel on that line, you would use LIRP. Now, the way LIRP works is that we expect, in this case, two values, P0 and P1, but we also need to provide a time value, most commonly known as t. This value has to be between 0 and 1. If t is 0, our object will be at P0. If t is 1, our object will be at P1. And then if it's somewhere in between, it will obviously be somewhere in between on the line. So if you want an object to travel on this line for, let's say, 10 seconds, 15 seconds, some sort of internal clock needs to be held in order to get the current time divided by the total time, because t needs to be between 0 and 1. It cannot be 10 or 15. So we need to get it between 0 and 1. So the mathematics behind this is 1 minus t in parentheses times P0 plus t times P1. That is the LIRP functionality. So this is an example of just 2 points, which results in a line. Now, when Bezier curve comes into play is when we have 3, 4, 50, 100, or 1,000 points. It can be nth degrees in points. And what we need to do is we need to use the LIRP functionality we just discussed. All right, so let's take a look at a example that has 4 points: P0, P1, P2, and P3. We essentially need to do the exact same thing we did with only 2 points, except for we need to do it on all 4 points. So we need to do LIRP between P0 and P1, which will result in PA. We need to do a LIRP on P1 and P2, which will result in a point PB. And we need to do a LIRP between P2 and P3, which will result in a point PC. Now, PA, PB, and PC are 3 points. So we need to do it again. So we need to do a LIRP between points PA and PB, which will give us PD. And then we need to do a LIRP between PB and PC, which will give us a point PE. Now, PD and PE are 2 points. We need to do it again. We need to perform a LIRP between PD and PE, and that will give us a point PF. That is just 1 point, so we are done. So this is the basic concept on Bezier curves. You could have 50 points. The whole concept is you need to do a LIRP on all points. So between points 0 and 1, between points 1 and 2, 2 and 3, 3 and 4, so on and so on. Then you'll get a resulting set of points. In the example we just performed, we started with 4 points. So we initially did a lerp on all 4 of those points, which resulted in a set of 3 points: PA, PB, and PC. We need to repeat this process until we get a resulting collection of points with only 1 point, which is our final point. So it can be 3 points or 50 points. The exact concept applies. We need to repeat the process until we only end up with 1 point at the end. So the initial process we did was between P0 and P1, P1 and P2, P2 and P3, which resulted in 3 points. That's greater than 1, so we have to repeat the process with those 3 new points. That resulted in 2 points. That's more than 1. So we need to repeat the process, which will result in 1 point, and that's our end result. So that's the basics behind Bezier curves. The mathematics behind this is pretty complicated, but the actual coding is not so complicated. So let's take a look at an example of 4 points again, and we'll just go over the mathematics. So we have P0, P1, P2, and P3. As I mentioned before, we need to lerp between all these points. So we need to lerp between P0 and P1, which will give us a point PA. So that is 1 minus T in parentheses times P0 plus T times P1. And that is PA. We need to lerp between point 1 and point 2, which will give us PB as in boy. And the math for that is 1 minus T times P1 plus T times P2. We need to lerp between points 2 and 3, which will give us PC. And the math is 1 minus T in parentheses times P2 plus T times P3. As I mentioned before, we have 3 points. We need to do it again. So we need to lerp between PA and PB. And that will give us PD as in dog. And the code, after working it all out, results in 1 minus T in parentheses squared times P0 plus 2 times 1 minus T in parentheses times T times P1 plus T squared times P2. We need to perform a lerp between PB as in boy and PC, which will give us a point PE as in echo. And the code for that is, after working it all out, 1 minus T squared in parentheses times P1. So again, that's 1 minus T in parentheses, and we square that. Plus 2T, 1 minus T in parentheses, times P2. Plus T squared times P3. So PD and PE, PD is in dog, PE is in echo, that's 2 points. Again, our goal is to get it down to 1 point, so guess what? We need to do it one more time, which will give us a point PF as in Frank. And the resulting code for that is, after working it all out, 1 minus t in parentheses cubed times p0 plus 3t 1 minus t in parentheses squared times p1 plus 3t squared 1 minus t in parentheses times p2 plus t cubed times p3. So that is our final point, and that is the math behind all of that. Alright, so that is it for this video. I hope you enjoyed it. We will go into a video where we will discuss the algorithm in great detail. I thought about including it in this video, but I like to split them both into separate videos so I can focus a lot on the algorithms instead of tying this video down. Just keep this centric to the mathematics side, and we'll keep the other video centric to the algorithm side, and a person interested in both can watch both. Alright, so I hope you enjoyed this video, and stay tuned for the next one in this series. I'm not sure what I'm going to cover next, but it should be pretty interesting. Well, thanks for watching. I hope you enjoyed this. Please give a thumbs up or a like if you enjoyed this. Add a comment if you want to as well. Feel free to take this link and share it, put it on your own site, embed it, whatever you want to do. That's fine with me. Anything that I mentioned that you need resources, be sure to check the description below. There will be links for those. If I missed anything or if a link is dead, please post a comment or find a way to contact me. You can go to my website and use the contact form. Want to be sure that all the links are still live and going. So, stay tuned for the next video.